Okay, this is a short video on the chemical shift artifact as it's been presented in this week's journal article, which is Hood et al. In Radiographics. So what I'm showing here is figure 3 from that paper, and I'm pointing here with these red arrows to this red arrow is pointing to the dark banding artifact on the left side of the patient's left kidney, and this arrow points to the bright banding artifact here. So on this slide, what I've done is I've just made the image transparent, highlighted some different anatomy, and I overlaid this yellow region on the fat on the left side and a darker region on the water. And I just want to show, just by an animation, what happens when you turn the gradient on if the gradient is in the X direction and it has this polarity. Let's go back again. So if I turn this gradient on again, you see that fat has moved from its original position to the left. And it's moved to the left because the gradient has this direction. Okay, so what we see here is when the fat moved because of the gradient, because of the Reed gradient, the fat has moved, shifted into water. So remember, the chemical shift is the shift of fat relative to water. So if fat is surrounding an object of water, then when it moves into it, you're going to see a bright band, where the bright band is the signal. It's bright because you're getting signal from the fat and the water. Or the apparent spin density here has been increased. Now, as fat moves away from the water object, you get a signal void, which is indicated by these dark bands here, because the apparent spin density in these areas has gone to 0. Now, I say apparent because remember, the MR image is a representation of the true. It's an estimate of the true spin density. We want the image to be an accurate spin representation of the spin density as much as possible. But for this instance, when we have a chemical shift artifact like this, that's not always the case. So in this week's discussion, I also asked what would happen to these banding artifacts if the gradient was moved to be in the Y direction. And what would happen is the banding artifacts would move from being on the left and right side of the organ to the top and bottom, or superior and inferior margins of the organ. And for let's just look at the dark band. If the gradient were in the Y direction, the dark band would depend, the position of the dark band at the top or bottom of the organ would depend on the polarity of the gradient in the Y direction. Okay, so remember, we have these positions of the dark and bright band because of this polarity of the Reed gradient. This polarity of the Reed gradient tells us that frequencies on the right side of the image are higher than frequencies on the left. And since fat moves towards lower frequencies, fat will shift in this direction. Okay, so if there are any more questions about this particular figure or chemical shift in general, please let me know. Thank you.